Just a minute. So, sideboard. Where is sideboard? All right. So these slides are visible to you?
Yes, sir.
Okay. So we talked about this slide at the last meeting, and I was talking about the types of virtualization, where we saw emulation, full virtualization, and para-virtualization. Just to repeat, emulation was pure software implementation. Full virtualization and para-virtualization are actual virtualization techniques where most of the instructions are run directly on the hardware. And for certain instructions, we need to do certain things like modification to the operating system, or doing a binary translation or emulation for them, right? So full virtualization follows direct execution plus binary translation. Para-virtualization follows direct execution and ignorance, right? So in summary, para-virtualization is better. Full is little inferior as compared to para-virtualization. Coming to the fourth type of virtualization, which is OS level virtualization. In this virtualization technique, what we have is an interesting aspect. So let me ask you a question, because I gave you an example of OpenSolaris last time. When a cloud provider is creating an infrastructure so that people can take it on rent, what kind of virtual machines it should have? What sort of operating system should it have? It needs mixture of operating systems, right? Some consumers may want to have Windows, Linux, right? Linux have hundreds of variants. Windows have multiple variants, right? So multiple operating systems are there, right? But the number is still handful, right? Not a very large number, right? But think about a provider who provides virtual machines or guest operating systems at little less cost, but there is a problem with that provider that all the operating systems which it provides are given to 18.04 LTS, same operating system. Would it be a problem in getting the business?
Not necessarily, sir.
Why?
I mean, if we're talking about a business, even though we are providing the service and there might be a difference in the quality of service, it also comes down to how they market their services.
No, but there might be certain consumers, they may ask, we need specific operating system, right?
Yes.
In that case, that provider would not be able to provide that service.
Right? Yes, they won't be able to.
But this is not a big problem, because the largest share in number of services which you get across the cloud is web service, right? People go for cloud for web services, right? So most of the consumers would like to have web services there, and a typical web service take is LAMP, right? I hope you all know LAMP, LAMP. Yes.
Yes, sir.
Right? Okay, what is LAMP?
So I've used LAMP once, like it was a local server thing, but I do not know what it is in full detail.
Okay, anybody else would like to try without doing a Google search? Okay, see, LAMP is basically Linux, Apache, MySQL, and PHP. Linux, Apache, MySQL, PHP. These are the 4 things you require to set up a typical web server. Yes or no? So,
Yes, sir.
so the most common implementation of a web server in this world is actually, this one: Linux, Apache, MySQL, PHP. L for Linux, Apache, MySQL, and PHP. Now we have multiple alternatives actually today. Instead of Linux, you may have Windows, right? Instead of Apache, you may have Nginx, Tomcat, right? Instead of MySQL, you may have a NoSQL database. You may have MongoDB, right? And instead of PHP, you have large number of frameworks available, and you may want to use any one of them. But this is a typical structure, and this is the most common web server which is available, right? So suppose a cloud provider says that I will be a pure web server, cloud provider, and I'll have most of the machines, most of the VMs running guest operating systems having Linux, Apache, MySQL, and PHP. In that case, they may have the same Linux kernel for all the virtual machines. Yes or no? And if that is the case, instead of having so many kernels for so many different operating systems, if I have a single kernel on the whole physical machine, and I run 10 virtual machines having 10 guest operating systems sharing the same single kernel image, would it be a problem? Let me explain you this in little detail. Ubuntu 1, Ubuntu 2, Ubuntu 3, Ubuntu 4, all are having same operating system, but you can do any other activities as you want, but their kernel remains same and there is a single kernel image. Would it be a problem? So while installing the operating system, if I install these 4 VMs, I just need to reuse the kernel image already installed in U1. U2 will use the same kernel image, U3 will use the same kernel image, and U4 will also use the same kernel image.
Sir, but they're copies of each other, right? I mean, they're not sharing it like as a core.
No, they're sharing it, single image.
Then it won't be a problem if the kernel is like changed for one user. Then it will affect all other users as well.
Okay. And why would a user change the kernel? Except the attacks or mischievous activity. Otherwise, regular activities, do you require to change the kernel?
No.
No. Anybody else? So this is a very interesting thing. Single kernel image, multiple VMs, multiple guest operating systems using the same kernel image. Kernel images we generally don't change. These are mostly reading, and you execute those codes in the RAM, and that's all. You generate the outputs and system calls, right? So having a single kernel image would not create a problem, except there are problems related to security, which may be there, right? So you may want to have this specifically for a purpose where you want many VMs, but you are not worried about, you are not worried about you are not worried a lot about security. This term should be there a lot, right? And you will have greater memory utilization. Do you all agree with me? Multiple kernel images will take a lot of memory, right? Single kernel image across VMs, memory will be optimized, and you will be able to use the RAM for other purposes, right? And your single kernel image will always be in RAM, right? Not a lot of swapping will not happen, so always you will be able to use it. So this is what the OS level containerization or OS level virtualization which we saw.
Sir, can there be a difference in like performance in all OS? So like if the kernel is same, but each OS is utilizing the resources in a different manner, so there can be performance issues in each other, right?
Okay, see, you asked a very important question, and this thing is known as interference, performance interference. One OS may use more resources, another OS may use less resources, right? And it might also so happen that you may be worried about a single kernel image being shared, right? But whenever you are running something, it will all be in the form of processes. So you will get that data copied, and even you may want to follow copy on write for that purpose. So performance interference per se would not be highly isolated. You are right. So in that case, what we do is we create zones, Z-O-N-E, zones, or people call them containers as well, right? And with that, we keep resource limits so that each guest operating system use only the specified amount of resources, right? So we had that worry, and that worry is solved using containers, right? So open Solaris containers are the classical containers. Today we see Docker containers or Kubernetes pods, right? So they also work on a similar kind of mechanism where we are creating containerized resources in which processes run, right? Otherwise, having a single kernel image because of that would not create much problems, right? Because whenever your VM is running, you have your own memory space. You are referring to that kernel image for copying, and that is always in memory, right? And you are using it for reading, right? So most of the kernel data structures or buffers, they have single writer, multiple reader thing, right? So you don't need to acquire locks all the time because it is mostly reading. And if you really want to acquire the lock and you want to change the kernel data structure, then it will be writing. And then in that case, we need to see how to do it, right? Does that make sense, Tanmay?
Yes, sir.
Okay. So let us quickly go ahead. Emulation. An emulator duplicates the function of one system using a different system so that the second system behaves like the first system. Processor emulation example is KEMU. Works on dynamic binary translation, right? KEMU.org is the website you may want to see. I always, remember emulation as native to non-native, right? Running, underlying hardware is native, and the created virtual environment is running on non-native architecture. This is what emulation is. Full virtualization. This is an example of full virtualization is Gen. Gen and KVM can use full virtualization. Full virtualization uses hardware features of the processor to provide total abstraction of the underlying physical system, right? People also call bare metal, right? So bare metal is virtual machine monitor getting installed directly on the hardware. Do you all know what is bare metal hypervisor? Bare metal, or should I explain it?
Like it's installed on the core system itself,
Yeah.
and we are not
So instead of installing an operating system first and then hypervisor, you directly install the hypervisor. And hypervisor works similar to an operating system, right? That is known as bare metal. Most of you, when you use VirtualBox is not bare metal. It is type 2, right? First, you install an operating system, then VirtualBox is installed as an application, and then you create VMs, right? So that is not a bare metal hypervisor. Installing a bare metal hypervisor is a good thing, right? The host operating system is optimized, and you have a lot of control over the VMs from there, right? So that can be done. No modifications are needed in the guest operating system. The guest operating system and any applications on the guest are not aware of the virtualized environment and run normally. I would like to highlight that the modification of the operating system is saving here, right? But that is not an overhead. Once you have a mechanism which kernel parts you need to modify, then automatically you can modify. Remember, when you do para virtualization in Gen, they don't ask you to modify, they automatically modify your kernel, right? Because this responsibility they don't leave to the user, they do it and it will be automatically installed. If you look at this diagram, the ring 0, 1, 2, 3. Ring 0 is VMM, ring 1 is guest operating system, ring 2 is nothing, and ring 3 is user applications. So most of the aspects are directly running. Some guest operating aspects which require issues, they are going to VMM and then they are being run on the system hardware, right? And this is known as binary translation, software implementation. Coming to para virtualization, it presents a software interface to virtual machines that is similar but not identical to that of the underlying hardware. Similar but not identical. This is a very good word they have chosen to explain this. Why not identical? Because there are certain instructions which we will ignore, right? So the processor is same, but those instructions will not be able to run. The intent of the modified interface is to reduce the portion of the guest's execution time spent performing operations which are substantially more difficult to run in a virtual environment compared to a non-virtualized environment. See, this is the main purpose that the guest runs, right? Can we go with running those operations directly, right? And for that purpose also this is considered as this. And how do you run those instructions or those kind of calls? We will define a specially defined hook known as hypercalls to allow the guests and host to request and acknowledge these tasks. This is a specialty which they provide, right? That when you want to talk to kernel, you do system calls. When you want to talk to VMM for specific purposes, you do hypercalls. Hypercalls are also like system calls or function calls, but they talk to the virtual machine monitor. Para virtualization requires the guest operating system to be explicitly ported. Explicit modification is required when you do para virtualization, and that is done by taken care by the virtual machine monitor. For their installation scripts, they change the operating systems. Ring 3, user applications are directly executed. Ring 0, your para virtualized guest operating system is running. Virtualization layer is also there, and then you are running it on the hardware. Now, if you look at this and the previous diagram, you would see that the guest operating system is running in ring 1, and there the ring 0 is running both para virtualized guest operating system and virtualization layer, because we have modified it in such a manner that it is capable of running in ring 0, and we'll take care about everything, right? So obviously the privilege level is higher and you have better performance as well. Hypercalls to virtualization layer replace non-virtualizable OS instructions. Those instructions which cannot be virtualized, they have been replaced. So these were the 3 techniques. 4th one we saw in detail, the OS containerization and OS level virtualization. Now let us talk about this host-based input-output. And this, if you see, I talked about the direct IO and host-based IO when I was speaking about host, IO virtualization. Remember, in the last meeting, I was talking about CPU virtualization, what additional layers are included as overhead. Similarly, memory, days IO. In IO, I said that the host operating system may help you. So what you will do? Guests will have driver front ends. They will be talking to drivers installed in the host operating system. And on your behalf, on guest operating system's behalf, the host operating system will talk to the hardware. Right? This is known as host-based input output. Device driver handling by host operating system. I also talked about direct IO, where I said that the guest operating systems can directly talk to the IO devices. And it is also possible. Remember, we had an interesting discussion that the hard disk of a guest operating system is actually a file on the virtual machine monitor or host operating system, right? So all the file IO calls are converted into disk IO calls. And this also adds one additional layer of overhead, right? So if I conclude all the four resources, we have one additional layer of overhead, right? So let me ask you this question so that I come to know that we all are on the same ground. So what is the overhead in main memory? What is the additional overhead in the main memory virtualization? Can anybody repeat? What was the overhead in the main memory virtualization? CPU virtualization. What is the overhead? जो नॉर्मल ऑपरेटिंग सिस्टम पर हम चलाते हैं सीपीयू को, जब वर्चुअलाइजेशन करते हैं तो क्या एडिशनल ओवरहेड आया था? Anybody? Chat. Memory, yes. Yes, Ayush. Memory question mark. Doesn't say anything in this. Can you open your mic and see?
Hello, am I audible, sir?
Yes, yes.
Yeah. So I guess it was memory, if I'm not wrong. The overhead was the additional usage of CPU or memory.
No. When you are doing memory virtualization, what is the overhead? When you give memory to multiple VMs, what is the overhead? The overhead is one more address conversion, right? Physical address conversion, logical to logical, then logical to physical. That additional layer of conversion was required, right? If you recall,
Right,
from similarly for CPU scheduling, one more scheduling layer is being added, vCPU to pCPU scheduling, right? Because the ULT to KLT scheduling was already happening and KLT to processor scheduling was already happening, just the processor to processor. Because right now we have virtual processors when we are using virtualization. So vCPU to pCPU scheduling has to be done. Similarly, in the disk, I just now said, disk is not original disk, right? It is a file on the disk. For all virtual machines, you get files, big files as the disk for them, right? Inside that, they may have their own file system, but it is files inside a file, right? So again, there is one layer of overhead. See, why I'm repeating this whole thing is virtualization has overheads, and this overhead is coming because you are showing every individual process that they have independent resources, and taking care of that, you require this additional overhead. And this overhead is not less, right? There are many papers which report that virtualization overheads are between 5 to 10%, but at times I think it is more, right? So virtualization comes with a lot of advantages, but there is a disadvantage of additional overhead, and which has a cost, right? Does it make some sense? Or anybody has a question? Okay, so let us move ahead and let me talk about the next virtualization technique, which is hardware assisted virtualization. So let me tell you that what are the challenges with the processor which has 4 rings, ring 0, ring 1, 2, 3. They had the problems of sensitive versus privileged. Now, when we go inside, instead of sensitive and privileged instructions, there are more things which are to be seen, right? And they can only be realized when you look at the challenges posed by them. So let me quickly talk about those challenges. First one is ring aliasing. We all know what is aliasing. Aliasing means another name, but maybe the another name, right? So if I tell you what is hardware assisted virtualization, in addition to the 4 rings, they also had one another ring, which is known as ring 0 dash. Ring 0 dash, which is similar to ring 0, but it is not ring 0 because ring 0 can be only 1. So what people said that in new hardware architecture, right? Because Intel, AMD, they created virtualization enabled processors later. And those processors follow Goldberg's requirement completely. But they cannot change the ring architecture. So what they did, they added one additional ring, ring 0 dash, right? So they address certain problems. First one is ring aliasing. The problem that arises when software is run at a privileged level other than the privileged level for it was written, right? So suppose there is a software which is run for ring 0. Operating systems are tend to run at ring 0, but you are saying that we will run them at ring 1. Then there will be problems, right? This is what it is saying. An existing OS may be written to run with ring 0. VMM must also run with ring 0. Guest operating system, they need to be deprivileged. Deprivileged means we need to demote them. They will run at 013 or they will run at 033. So 0 is VMM, 1 and 3 for guest operating system as applications, or on 64-bit operating systems, it is 0/3/3 means 0 is VMM, and on 33 you run guest operating systems and applications. Another interesting aspect is an operating system can know whether it is directly running on hardware or it is running on top of a virtual machine. And this is a very, very important thing. If an operating system can know whether it is running on real hardware or a virtual machine, if it can know this, what do you think? What would be the harm to us?
Sir, I missed the last time. Can you please
Let me
repeat?
repeat. There is a virtual machine on top of which an operating system is running. And there is a physical machine on top of which an operating system is running. Can operating system know whether they are running on virtual machine or a physical machine?
They won't.
They won't be. Why?
Because even if it is running on a virtual machine, it is like shown to them that they have a hardware. They own it, but they really do not own it. So it's like it is there, but they do not know whether it is like physically existing or virtually existing.
But you see the last line here. A guest operating system can know its run level by this instruction, push CS. CS contains the current privilege level.
Yes.
CS. So in that case, they will be able to know whether they are a virtual machine running on a virtual machine or a guest or on a physical machine.
But sir, is it possible to assign them the highest level while they are on the virtual machine? So wouldn't that be confusing for the system?
Yeah, so we will not assign them ring 0. We'll assign them ring 0 dash on new processors. On old processors which do not follow virtualization, we'll never assign them ring 0. Okay.
Yes.
But now my question again is still unanswered. If they know the run level, what would they do? Or what is the harm if they are able to know the run level?
I mean, there is no harm unless it's a AI who is looking for more resources.
Anybody else would like to give a try?
Sir, I can think of one alternative, like if it is being provided as a service and they know that, okay, they do not have the hardware and they are being charged high. So they can question the provider that I'm paying this much, but I'm not getting this much, even though you have resources.
No, but
Something.
it doesn't tell you whether you are getting the real resources or not, because it's just telling the run level, right? And you already know that you are going to get a virtual machine. Okay? So how would you raise that concern?
If let's just say I am the only like signing up for that machine and they have provided it to someone else as well,
So you are saying
unknown
that
to my information.
I think you are saying that you have been charged for dedicated resources, but they are giving you shared resources.
Yes.
Okay. So, but looking at the run level, how would you know that whether the resources are shared or not? This is my question.
So we are paying for a specific amount of resources.
If you
but
say
if we are
that,
not getting the
I asked for a physical machine, but they are giving me a virtual machine. That is
yes.
That is valid. But if you say that I asked for dedicated CPU, but they are giving me virtual CPU, they're giving me virtual CPU. Okay. And you ask for a dedicated CPU, then also this cannot answer that question. Because even if you get a dedicated CPU, still you will run on ring other than ring 0. Right?
Sir, like if we have asked for 8 dedicated CPUs and we know like what the performance of the CPUs are, but we are not getting it, then we would question that, okay, there's something wrong.
There's something wrong. But that question you can ask always, but this run level doesn't answer that. This
Yes,
is what
it does not.
Yes?
Yes, it would not answer that.
It would not answer that. Okay, one more thing which I think is very important. See, there are many there are software, there are malware, right? We all know, we have heard about malware. So when you test the malware, you think you have a software which you think may be a malware, maybe a software, you are testing it, you are analyzing it. Where do you test such malware? You test them in specifically designed sandboxes. I'm using a term sandbox. Let me write this. We all know about sandboxes.
Used it, but do not know like what is the definition of it.
So sandbox is a actually resource container which allow you to run a process inside with certain limits so that it doesn't harm your computer. Second thing is they continuously monitor certain aspects of that software, what system calls it is making, what network connections it is making, what is happening on the network, right? So then the sandbox is kind of a virtual machine, right? And this push CS instruction tells you where you are running, right? So suppose you are running a malware inside a virtual machine to test it, malware will try to see whether it is running in a virtual machine or it is running on a physical machine, though it's not very clear, but it will stop showing its real actions if it come to know that it is run inside a sandbox. It will change its behavior and only show good things about it. All bad actions it will hide because it has just now came to know that, oh, they are running me inside a sandbox. Let me become a normal calendar instead of a malware. So trying to know what execution environment you are running in, many software may change or many malware may change their behavior and would not show the real working. Right? This is also another possibility. Address space compression. VMM must use some of the guest's virtual address space to manage transition between guest operating system and VMM. This is also another very important idea. VMM has RAM. In that RAM, we have separate RAMs for every virtual machine. But in the guest operating system's virtual address space, right, we should have some amount of RAM which is there to help us in transitioning between VMM to guest and guest to VM. Similarly, the interrupt vector table can be kept there, right? So for Intel architecture, IA is known as Intel architecture 32. Interrupt description table uses linear address. For Itanium, Intel vector table resides in virtual address space. VMM's address spaces must be protected. This is a minimum requirement we should all have. Non-faulting access to privileged state. Most of the time, the privileged states should be faulting. Faulting means there should be a trap that there is a privileged instruction and everybody should know. At least VMM should know. But we know there are certain instructions where it will not happen. In most cases, accessing privileged states result in faults. However, some instructions can access privileged states without faulting, right? For Intel architecture 32, GDTR, IDTR, etc. are only writable at ring 0, but they are readable without causing faulting, right? For Itanium, PTA, page table address register is only writable at ring 0. Fetching instruction indirectly exposes the value. These are certain examples of these instructions which do not require privileges, but they are sensitive. Right? A guest OS may find the inconsistency by attempting to write first and then reading, right? Adverse impact on guest system calls. System call जब शुरू होती है तब ये लिखा हुआ आता है sys enter, खत्म होती है तब लिखा आता है sys exit. I should tell you a very interesting system call known as trace. किसी को पता है इसके बारे में? trace. Anybody?
No, sir.
Okay. So trace is known as system call trace. Very, very useful command for operating system monitoring, security, networking, right? Identifying or analyzing a software, malware, virus. This is known as trace. So if you run system call trace or trace with a program, so program will be run, and whatever the program is doing, you don't have the code of the program, let us say, but whatever the program is doing, every system call with its parameter, how much time it is taking, will be shown to you over terminal. Please try this. This is a very interesting command, right? But the question is, adverse impact on guest system calls. System calls are made via sys enter and sys exit. Low latency than the traditional software interrupt. Sys enter and sys exits दोनों कहाँ चलते हैं? एक तो रिंग 0 पे चलता है और एक बाहर रिंग 0 के बाहर आके, क्योंकि वो यूजर मोड में जाके खत्म होती है, राइट? So this has to be emulated. तो जेन ने तो किया ही है इसको हाइपर कॉल्स के नाम से. Interrupts virtualization. How would you handle the interrupts? I told you earlier कि I'll keep a virtual interrupt table for every guest and handle them. Ring compression. Ring compression is segment protections do not apply in 64-bit, right? So 64-bit and 32-bit architecture are completely different. Protection between segments is not available in 64-bit. 32-bit it is available. And pages or paging does not distinguish ring 0, 1, 2. So what will you do? You run guest operating system as ring 3, then it is a problem, right? Application jahan run ho rahi hai, wahi guest operating system run ho raha hai. This is another problem. बार-बार frequent resources access करने पड़ेंगे. Frequent access to privileged resources. This is required for the guest operating system, right? So these are the challenges. Let us come to the solution. Solution is both processor manufacturing companies created their virtualization enabled hardware. One is known as Intel Virtualization Technology, Intel VT. Another one was used to be known as AMD Wonderpool Technology, Wonderpool, but later they also changed the name. It is AMD Virtualization. So what they will do? They will do a very interesting thing. They said that let us create a control structure for each virtual machine. Like we have process control block for every process on a normal operating system. Here, for every VM, we will have virtual machine control structure. Virtual machine control structure is a new data structure. VMCS includes guest state area, host state area. Guest state, host state. Because every virtual machine will be running in a guest operating system, they will be going from guest to host, host to guest, and they will keep those data there. A transition corresponding state is loaded, saved. VM is either running or not running. So this data structure in the main memory will keep the information about that virtual machine. External interrupt exiting and interrupt window exiting. What are these? Suppose there is a interrupt to the VM, right? These are external interrupts. Those instructions will stop the VM, and they should stop because we want to do whatever we want to do with the normal operating system. Interrupt window exiting is if we set it, VM exit occurs when ghost operating system is ready to receive interrupts, right? So these two things can be done. So what is Intel Virtualization Technology X architecture, VTX? VTX has added some interesting things. First thing is a new register, a new processor status register bit, PSR. If it is 1, it means guest operating system is running. If it is 0, it means virtual machine monitor is running. This is a very good thing. 1 bit can tell you who is running right now. Okay. Coming to address space compression, there are two things, VTX and VTI, Virtualization Technology X and Virtualization Technology I. There are two versions which they created. With VTX, virtual machine exits and virtual machine entries. जब भी VM run होने के लिए आती है तो बोलते हैं VM entry, run होके हट जाती है VM exit, because it is time slicing which is happening, right? So VM exits and VM entries change the linear address space. VMM and guest reside in a separate virtual address space. And this is the best used because in public clouds, we want that there should be complete separation. In VTI, the VMM has a virtual address bit that guest operating system cannot use. And VMM has exclusive use of half of the virtual address space. This is VTI. How do you do ring aliasing? We add another ring, ring 0 dash. I'm writing it here, ring 0 dash is added. Ring compression. We allow VTX and VTI to run at ring 0 dash. There is no problem. So that problem is solved. Solving challenges with VT. Non-faulting access to privileged state, right? So either you run in VMM or you run in ring 0 dash. There is no problem. What will happen to the system calls? With VTX, a guest operating system can run at privilege level 0. तो वो जो प्रॉब्लम थी रिंग 0 पे न रन होने की वो सॉल्व हो गई है, right? And interrupts are already, I told you that we will keep an interrupt, software interrupt mechanism to solve it, and it will happen at ring 0. There is no problem, right? So what is the architectural support now? There are two modes on Intel Virtualization Technology, root and non-root. Root is VMM. Non-root is guest operating system, but they both are ring 0 and ring 0 dash. Transition operations, VM entry, VM exit. Transitions occur for sensitive instructions. When do you do this transaction? Sensitive instructions. Otherwise, to sab direct chala sakte hain, right? VM control structure. We saw the VM control structure. What it stores? It stores the VM state, and it is similar to process control block. We had PCB, right? and that is the same thing which we have here. VT architecture has certain more things, that you can have non-maskable interrupts, virtual processor identifiers, because vCPUs should have their IDs. So let me talk about a very interesting file on your machine. You should see while you create virtual machines, /proc CPU info and /proc mem info, /proc CPU info and /proc mem info. CPU info gives you CPU information, and mem info gives you memory information of your currently running operating system. So remember, whenever you will create CPUs, because you cannot manufacture CPUs, you can only create them virtually. All those CPUs information will be found out in these files, CPU information. This is a very important file. It will tell you what properties those CPU have, what features are there, what is enabled, what is not enabled. And it is a live file. Do you know what is proc/proc? I said it is a live file. What do you mean by live?
Running process.
See, this /proc is a very interesting directory on your machine. This directory starts at root, right? /proc means it starts at root. Yes. But this /proc is not available on the hard disk. It is not available on the hard disk. Can we have a directory which is not available on the hard disk?
CPU has some cache memory.
No, the cache memory is something else. These are the
Oh,
files,
okay.
right? These are the files. This is a very interesting directory /proc. So in interviews, people ask this question when you're talking about system security or networking or higher level operating systems, that on my machine there is a directory known as /proc. There are many files. When I switch off the computer, get the hard disk out and mount this hard disk to another operating system, I don't see this folder /proc. What may be the problem? Student give a lot of different kinds of answers, that my directory might be corrupt, the directory might not be saved properly, this and that. But the answer is pretty interesting. Can anybody answer this?
Maybe it is created and like shut down after the system shuts down,
Yes, that is true. But what is the purpose?
so that no one else can access it.
No, that is not the
Oh,
issue.
okay.
See, this is a live directory. This directory keeps information about everything which is happening right now. All the processes, memory, CPU, IO, file descriptors, having a separate folder for every processor, and that live information is always there. And your top command, top command gets every information from this folder. This is the live directory. Once you switch off the machine, this directory disappears, right? So the Linux operating system architecture has so many interesting things, and proc is one of them. So any processor you add, remove, increase and change the memory, all the information will be available in this directory, right? Please go and find out. This is a very interesting directory. Okay. Virtual processor identifiers. Every vCPU will have an identifier, right? Extended page table, because we need conversion. I told you that in memory virtualization, I need a separate conversion. So a separate set of page tables to translate from guest physical address to host physical address is required. Guest operating system can modify its own page tables and directly handle PA VMM, can avoid the VM exits associated with page table virtualization, which is a major source of overhead, and it will remain an overhead. We cannot do anything with this. Okay. See, I told you about direct input output and host based input output. So both the things are shown here in a single diagram. We already discussed this, right? In one case, virtual machines are directly accessing the devices. In other case, they are talking to virtual machine monitor, and virtual machine monitor is doing work on their behalf. So virtual machine, this is host based IO, this is right. So let us summarize what is hardware assisted virtualization. In 2005 and 6, Intel and AMD working independently. This is true. This has to be written specifically. Created new processor extensions to the x86 architecture called Intel VTX and AMD V, respectively. On the Itanium architecture, hardware-assisted virtualization is known as VTI. Itanium is also Intel, right? The first generation of x86 processors to support these extensions were released in 2005 and early 2006. On November 13, 2005, Intel released two models of Pentium 4, 662, 672, as the first Intel processor to support VTX. Again, in 2006, AMD released Athlon 64, which is also known as Orleans, and 64X2, known as Windsor, as the first AMD processors to support this technology. Well-known implementations of hardware-assisted x86 virtualization include VMware Workstation, the Gen 3.6, 3.x, Linux KVM, Microsoft Hyper-V. Today, every hypervisor follows hardware-assisted virtualization because most of the hardware is new now, which follows Intel virtualization or AMD virtualization technology, right? You may want to see these two interesting utilities: Intel processor identification utility or Microsoft hardware-assisted virtualization detection tool. These two utilities will tell you what kind of CPU you have, whether it has virtualization or not, what kind of additional features it has. Everything will be given to you. If you don't like this, go to CPU MEM info, you'll find out more. If you don't like that also, go to BIOS and find out everything, right? So here comes the detailed discussion about the virtualization. We would complete that part. In case you have any questions, please raise them now. Then we can start talking about Gen virtual machine monitor, Gen hypervisor. Do you have any questions?
Sir, I had a question from last class regarding emulators. So I use an emulator which is for a gaming console. So it has these options of hardware emulation and software emulation. So I'm getting confused between the two because hardware, they are replicating the hardware that is available on the game systems, which are sold physically. But then software is also running separately and they clash sometimes. So what can be the reason?
See, I need to see that, but from your question, I can get an initial feeling that when they're talking about hardware emulation, and that must be really fast because they may be directly running certain parts of the instructions if they found out a match, right? And if that match exists, emulation will be quite faster. And remaining instructions, they need to do software emulation, right? Suppose addition, increment, decrement, moving to a memory location. Almost these common instructions are available in every processor. Maybe some changes there, but most of the times we find out these instructions. These are known as regular instructions, right? So for them, they might have directly running on the hardware because many emulators do it.
Yes.
Right. So you might find a clash, or I would say that there might be a collaboration that certain part is run directly on the hardware, certain part is directly run on the in the software. In pure software emulation, it is completely on software, whether you have that instruction or not. But ultimately, the conversion will happen. Thing will run on hardware, right? That everybody should know. कई बार क्या होता है, स्टूडेंट ऐसा याद रख लेता है कि सॉफ्टवेयर मतलब केवल सॉफ्टवेयर. सी सॉफ्टवेयर रन्स ऑन द हार्डवेयर, राइट?
Yes, sir.
और कोई बात? मैं जो बताता हूँ तुमको समझ में तो आ रहा है सबको?
Yes, sir. मुझे तो समझ आ रहा है.
तन्मय, ओके, जय, साहिल, सार्थक, आयुष, ध्रुव, संयम. There are 2 Dhruvs. Yukta, Dhaval, Kandar, Yash, Samkit. So you all are in pre-final year or final year?
Sir, we are in MTech.
Sarthak is in MTech. So each one of you is in MTech.
Me, Sayam, Dhaval and Yukta. First year.
MTech first year.
Yes.
Okay, and others are in BTech final year?
Some of us are in BTech and some of us are in BSc.
BSc. BSc
Yeah.
Computer Science.
Yes, computer science. And
Okay.
in a final years only.
In a final. So your BSc Computer Science is 3 years or 4 years?
4 years, sir.
4 years.
BSc honors degree.
BSc honors. Yeah, great. Here we have a good mixture. But there are few who never raise a concern, never ask a question. I take it, that way that they're getting what I'm teaching. Yes, because at times it becomes quite technical. So okay, so we should all gear up for the next thing, which is Gen, right? So we have 15 minutes in hand. I'll use that 15 minutes in an interesting manner. I'm introducing a paper now, right? That paper is available in your repository. Kirtan, there is a paper known as Gen and the Art of Virtualization. Gen and the Art of Virtualization. Can you look in the folder if it is available?
Sir, we are really sorry, but sir, we are having lecture at 2:30.
No,
So if
2:30.
it is okay for you, so we can leave at 2:20.
Yeah, you can leave, but 2:25 is also okay, no? For what you require in attending a new lecture, it is just signing out and signing in to another link, or it is a physical lecture?
Physical lecture, sir.
Physical lecture. Okay, so please leave by 2:20. In that case, we'll not start. Just I take 2-3 minutes in discussing something. Okay.
Okay, sir. Thank you.
Okay. So, Kirtan, could you find out that paper?
Sir, I could not find the folder, but I can look for it online as well.
Okay, so let me show you it on the screen. Which
Sure,
paper
sir.
I'm talking about. This is another paper. I'm talking about this paper. Gen and the Art of Virtualization.
Okay, sir. Yes, I found it.
This paper is there. Yes. And I have sent a paper in that folder, which is also highlighted. So if possible, that highlighted paper, please share with the group, right?
Okay, sir.
So
Sir, I think, you might have shared the folder with Professor Chaudhary.
yes. So what I'll do, I'll send this paper directly to you now. Okay.
Oh, okay, sir.
And that folder also you can share completely. There is no issue.
Okay,
Okay.
sir.
So this is the paper which we would see. We'll read everything on the board, but I would motivate each one of you to start looking at great papers which have changed the world. So one thing is book. Book is written after reading many papers, experiences, and then converting them into ideas and writing statements. But reading from who has created the software would be a great thing. And this also allows us to read something which is very complicated, but written very simplified manner. So this also allows us to how to read research and how to read great papers and comprehend them. Right. So this is a paper which is one of the finest work in the area of distributed system and virtualization. I treat it as a classical paper. The authors are all from academia. You should all give a lot of respect to academia. The innovation happens in academia. Industries are meant to exploit those products, use them in technologies, right? Many of the times I listen to a lot of industry people coming to academia for some lecture talks that engineers are not employable, this and that, blah, blah, blah. Right? I told them, you were also engineers at some point of time. You are doing some technology. We don't want to teach in the classrooms. We want to teach them fundamentals. They should be ready for any industry. They should not be ready for some specific company, right? So I'm very blunt on this. And I think Professor Chaudhary also shares similar ideas that we should all learn technological fundamentals, not new technologies, right? So even when we look at Gen or Gen APIs, we are just learning how things are created. Whether Gen is used by industry or not, that is a separate thing. Industries use new tools every 6 months, right? And they require more of application writers instead of application engineers. So this is a small comment. This paper was written by these authors, and these are at University of Cambridge Computer Laboratory. Today, Gen is known as Gen Server. Also, Gen is available as open source, but Gen Server is the product, created by the company known as Citrix. तुमने नाम सुना होगा Citrix का? नहीं सुना तो देखना चाहिए. जैसे VMware है, जैसे Citrix. This paper is pretty interesting. Students and their professors created Gen, and it changed the world of virtualization. It was published at one of the most top sorted, top sort conference known as SOSP 03. 2003 का पेपर है ना? और हम इसमें से जो हाईलाइटेड पार्ट्स हैं वो पढ़ेंगे कि जेन कैसे सीपीयू, मेमोरी, डिस्क, आईओ इनका वर्चुअलाइजेशन करता है, पैरा वर्चुअलाइजेशन कैसे करता है, इंस्ट्रक्शंस को इग्नोर कैसे करता है, राइट? एवरी पार्ट वी विल सी, राइट? So please share this paper, Kirtan. Another paper we'll see in the next session is this, which is comparing 4 types of hypervisors. A component-based performance comparison of 4 hypervisors. This is from George Washington, IBM TJ Watson Research Center, right? Their collaboration. Here we'll see how to compare hypervisors. Which one is better, which one is inferior, on what ground which one is better or which one is not, right? So in that case, I'll stop here and we'll share these 2 papers to, Kirtan, so that it can be shared to all of you, right? Yes, Kirtan.
Thank you, sir.
Yeah. Thank you,
Thank you,
everyone.
sir.
Yeah, if I forget to share, please remind me, Kirtan.